All right. Hi again. Now let's discuss on several types of ANOVA. Right? There are few types of ANOVA. The first one is one-way ANOVA, two-way ANOVA, and last one is MANOVA. Stands for multiple ANOVA. In this lecture, we only cover for two types of ANOVA. The first two, which is one ANOVA and also two ANOVA. Right? So as we now understand, yeah, the basic terminology behind the ANOVA, so let's dive deep into its implementation using a few examples. A recent study claims that using music in the class enhances the concentration and consequently helps students absorb more information. As a teacher, your first reaction would be skepticism. What if it affected the result of the students in a negative way? Or what kind of music would be a good choice for this? Considering all this, it would be immensely helpful to have some proof that it actually works. To figure this out, we need to decide to implement it on a smaller group of randomly selected students from three different classes. The idea is similar to conducting a survey. We take three different groups of 10 randomly selected students, all of the same age, from three different classrooms. Each classroom was provided with a different environment for students to study. For example, classroom A had a constant music being played in the background, classroom B had variable music being played, and classroom C was a regular class with no music at all playing. After 1 month, we conducted a test for all the three groups and collected the test scores. The test scores that we obtained were as shown in the table, right? Okay. Class A, constant sound. Class B, variable sounds. And class C with no sound. So these are all the value data that we have collected, right? 10 score randomly out of 10 students, as shows in the table in the slide, right? Now, now we will calculate the means and the grand mean. So in our case, and you can see here, the grand mean value is 5.1. The grand mean value is, the mu is equal to 5.1. So looking at the above table, we might assume that the mean score of students from group A is definitely greater than the other two groups. So the treatment must be helpful. Maybe it's true, but there is also a slight chance that we happen to select only the best student from class A, which will result in better test score. Do remember, in the beginning, the selection was done randomly. So this leads to a few questions such as, how do we decide that these groups perform differently because of the different situation and not merely by chance? In a statistical sense, how different are these three samples from each other, class A, class B, and class C? What is the probability of the group A students performing so differently than the other two groups? So to answer all of those questions that just pop up in our mind as a statistician, first we will need to calculate the F statistics, which can be expressed as the ratio of between groups variability and within group variability. Right? So let's complete the ANOVA test for our example with the alpha set at equal to 0.05. So all of the value SS between, SS within, DF between, DF within, MS between, MS within, and F value are stated, is calculated, and that is the value. Right? Okay. So what is the limitation? Before that, what is the limitation of one-way ANOVA? Right? So one-way ANOVA tell us that at least two groups are different from each other, but it won't tell us which groups are different. If our test returns a significant F statistic, we may need to run a post hoc test to tell us exactly which group have a difference in means. Next are the steps here to perform one-way ANOVA in Excel along with a post hoc test. Right? Right. So here are the steps here to perform one-way ANOVA with post hoc test in Excel. I won't go through it one by one. You may read it later in the slide from the step 1 until the step 7. Right. So in the end, yeah, the result of your example of class A, class B, and class B will resulted as shows in the slide. Okay. So here, yeah, we can see. Let me open back the pointer. Okay. So as you can see, yeah, the F value is greater than F critical value for the alpha level selected at 0.05. Therefore, we have evidence to reject the null hypothesis and say that at least one of the three samples have significantly different means that thus belong to an entirely different population. Right? So another measure for ANOVA is the p-value. Alright, so here is the p-value, yeah, 0.001669. Right? So if the p-value is less than the alpha level selected, which is in our case, yeah, because we set it 0.05, right? So we reject the null hypothesis. There are various methods for finding out which are the samples that represent two different populations. Okay, I will list some for you. The first one is Bonferroni approach. Second, least significant different test. And the third one is Turkey's HSD. Right. So I'm going to show you only one technique, which is Bonferroni approach. Okay. You can do it later in the Excel based on the step that I have already stated in the slide. Yeah, from step 8 until step 11. Okay. So this is the result. Okay. Here, the result of the Bonferroni technique using the Excel. Okay. So here, yeah, we can see the p-value of A versus B and A versus C is less than the alpha level selected equal to 0.05. This means that group A and group B and group C, A and C have less than 5% chance of belonging to the same population. Whereas for group B and C, is much greater than significant level. So the p-value is 0.71, which is greater than 0.05, right? So it is clear that A, constant music group belongs to an entirely different population. Or we can say that the constant music had a significant effect on the performance of students. So, voila, the music experiment actually helped in improving the result of the students. Okay, so another effect size measure for one-way ANOVA is called eta square, ETA square, right? So it works in the same way as the R240 test. It is used to calculate how much proportion of the variability between the samples is due to the between group difference. It is calculated as n power by 2 equal to SS between divided by SS total. Yeah. Okay. And 60% of 60% of the difference between the score is because of the approach that we use. Rest 40% is unknown. Okay, because here we use the previous example value, so n power by 2 equal to 54.6 divided by 90, so it's equal to 0.60, which means that 60% differences. So hence, yeah, eta square helps us conclude whether the independent variable is really having an impact on the dependent variable or the difference is due to chance or any other factors. There are commonly two ways of ANOVA tests for univariate analysis. One-way ANOVA and two-way ANOVA. One-way ANOVA is used when we are interested in studying the effect of only one independent variable, IDV, or factors on a population, whereas for two-way ANOVA is used for studying the effect of two factors on a population at the same time. For multivariate analysis, such as technique called MANOVA or multivariate ANOVA. Right? So if you do a multivariate analysis, we use a technique called MANOVA or multivariate ANOVA. Okay.